Today we're going to be looking at linear programming. So here's our example. We're going to read it and do some close reading and underlining what we think the important information is. So a painter has exactly 32 units of yellow dye and 54 units of green dye. He plans to mix as many gallons as possible of color A and color B. Each gallon of color A requires 4 units of yellow dye, 1 unit of green dye. Each gallon of color B requires 1 unit of yellow dye and 6 units of green dye. We need to find the maximum number of gallons he can mix. So the first step we need to do is we need to define the variables. What are we talking about? So our painter has yellow dye and green dye, but together when he mixes those two colors, we could make color A and color B. And our goal is to find how many gallons that he can mix together to produce these two colors. So our variables are going to represent the number of gallons that he can make of color A as well as color B. So I'm going to let X equal the number of gallons for color A. And Y is going to equal the number of gallons for color B. The next thing is to write the objective function. And the objective function means, okay, our goal is to find the maximum amount of gallons he can mix. So we're trying to see how many gallons we can get of color A as well as the number of gallons we can get for color B. So our objective function is going to incorporate both variables, X and Y. So in function notation, we're going to call this f of x comma y because we're going to have two different variables. And so if I want to find how many gallons of each he can make, then I need to combine the gallons of color A plus the gallons of color B. So our objective function would be x plus y, since x represents the number of gallons for color A and y represents the number of gallons for color B. Now we need to write the constraints. He only has so much dye of yellow and he has only so much dye of green. And we have to have certain amount of requirements of the yellow and the green dye to make the two different types of colors. So our first constraint that we're going to be talking about is that we can't have negative gallons of paint. It's just impossible. So we know that the gallons of color A and the gallons of color B must be positive. So for that, it means that X has to be greater than or equal to 0. We could have 0 gallons of color A, but we can't have negatives. That means that Y also has to be greater than or equal to 0. Again, we can't have negative colors of B. The next thing that we underline is we said that color A requires 4 units of the yellow dye and 1 unit of the green dye. We said that B requires 1 unit of the yellow dye, 6 units of the green dye, and we only have 32 units of yellow and 54 units of green. So all of our green dye has to be less than 54 units and all of our yellow dye has to be less than 32 units because that's the only amount of dye that we have. So for color A, we know that we need 4 units of the yellow dye. So 4 times X. While B requires only 1 unit of the yellow dye. So plus Y, and that all of that yellow dye together has to be less than or equal to 32. We could use all of it or we could just use a portion of the yellow dye, but we cannot go over it. Then we also have the green dye. So in the color A, we know we have 1 unit of green dye, so X. In color B, we have 6 units of that green dye, so plus 6Y. Together, it would incorporate all of the units of green dye that we need, and he only has 54 units, so therefore it has to be less than or equal to 54 because we can't use more of the green dye than we already have listed. The next step is now we need to graph this. So here we have 2 main equations that are going to help us graph. We're going to look at another way of graphing. Instead of getting y by itself and doing slope-intercept, so our rise over our run and graphing our y-intercept, we're going to see how we can graph with using our vertices. So our first function that we had was 4x plus y is less than or equal to 32. So I'm going to build a table, and I'm going to be looking at x and y. So if I graph by my intercepts, that means that if I look for the y-intercept, that occurs when x equals 0. So if I plug a 0 in for x here, I'm going to have 4 times 0 plus y being less than or equal to 32. Well, anything times 0 is 0, so I could just cover that up, and I have that y is less than or equal to 32. So when x is 0, y is 32. The next thing I can look at is the x-intercept. So the x-intercepts occur when y is equal to 0. So if I put a 0 in for y, I have 4x plus y is less than or equal to 32. If I put a 0 in, so 4x plus 0 is less than or equal to 32, I'll have 4x is less than or equal to 32. Then divide both sides by 4, and 32 divided by 4 goes in 8 times. So when y is 0, x is equal to 8. We're going to repeat the same process for our other function. So here we have x plus 6y is less than or equal to 54. So I'm going to make my table, my x and my y's. I'm going to look when x is 0, what is y? So I'm going to have 0 plus 6y is less than or equal to 54. So 6y is less than or equal to 54. Divide both sides by 6, and 54 divided by 6 goes in 9 times. So when x is 0, y is equal to 9. Now I'm going to check, well, what happens when y is 0? So I'm going to plug a 0 in for y. So x plus 6 times 0 is less than or equal to 54. Anything times 0 is 0, so we kind of get to cover that up. And I see that x is less than or equal to 54. So when y is 0, x is equal to 54. So I'm going to be using these tables, these intercepts, in order to graph my function. Now we're going to look at graphing. So I rewrote my tables here for my intercepts, and I've also set up my graph. I defined x as the number of gallons for color A, so that's my x-axis here, and I defined y as the number of gallons of color B, so here's my y-axis here. Based upon my numbers, so I have 32 and 8 and 54 and 9, I chose to make a scale of 2. So I went by 2's on my x's and I went by 2's on my y's. So now we're going to be able to graph these functions. The first thing we need to look at is plotting our intercepts. So when x is 0, y is 32. So here's 0, 0, so x is 0, y would be up at 32. When x is 8, y is 0. So I'm going to go over to 8. And so now I have 2 points. I'm going to take my ruler and I'm going to connect these 2 points. my next function I had, when x is 0, y is 9. So 2, 4, 6, 8, 10, 9 falls between 8 and 10, so I'm going to put my mark there. When x is 54, y is 0. So on my x-axis, I have to go all the way out to 54 and plot a point. So I have 2 points. I'm going to take my ruler and I'm going to connect them. My other constraints I had was when x has to be greater than 0 and y has to be greater than 0. So that means that this x-axis is my line, because that is when y is equal to 0. This y-axis is another line, because that is when x is greater than 0. So I'm confining myself into this first quadrant area. Just like we've done before, is now we have to figure out how to shade certain parts of our graph. So I'm going to come back to my tables, and I'm going to start picking a test point. So based upon my graph, so I'm going to bring the graph back in, I need to select a point that is not on any of my lines. So I'm going to select the point 2, 2. That's what I'm going to be testing into my functions. So below here, I'm going to put my test points. And I'm testing 2, 2. So in my function here, 4x plus y is less than 32, I'm going to substitute a 2 in for x and for y. So 4 times 2 plus 2 is that less than 32. So 4 times 2 is 8, plus 2 is that less than or equal to 32. So is 10 less than or equal to 32, and that is a true statement. Then I'm going to test in my other function. So I'm going to be looking at 2 plus 6 times 2 is that less than or equal to 54. So 2 plus 6 times 2 would be 12. And we're seeing is 2 plus 12 less than or equal to 54. 2 plus 12 would be 14. That is less than or equal to 54. So that is a true statement. Our other 2 constraints that we had was that x is that greater than or equal to 0, and y is that greater than or equal to 0. So we're testing 2, so for to test our x, is 2 greater than or equal to 0? That's true. And for y is 2 greater than or equal to 0, and that is also true. So we have 4 true statements. So with our 4 true statements, we're going to come back to our graph, and we're going to shade where 2, 2 is. So I'm shading here, I'm shading below my green graph, and I'm shading to the right of my red, I'm shading above my x-axis, and to the right of my y-axis. So I've created my feasible region. And with my feasible region, I have to define it by the vertices. So here's 1 vertice, here's 2 vertices, here's my 3rd vertice, and here's my 4th vertice. So my next step in my solving is to define these vertices. So this point right here would be 0, 0. My next point up here is 0, 9. This vertice here, that occurs when x is 6 and y is 8. So 6, 8. And then my final vertice comes here when x is 8 and y is 0. Now we're going to test our vertices into our objective function to determine our maximum number of gallons that he can make. So in step number 2, we defined our maximum function as x plus y. So in step 6, you're going to take your vertices from step 5 and we're going to plug them into our function. So we have 0, 0. So it would be 0 plus 0 would equal 0. So this represents the number of gallons for color A and for color B. We have the next vertex we found was 0 and 9, so that would be 0 plus 9 would mean 9 gallons of paint. Our next vertex that we have is 6, 8, would be 6 plus 8, which would make, we could make 14 gallons. Then we have 8, 0, which would be 8 plus 0, which would be 8. So our question asked us to find the maximum number of gallons he can mix. So maximum means largest. So out of our outputs, 14 is the largest. So here's the max, and we know it's the max because this is the largest number in your table. So step number 7, we have to answer our question. So we're looking for the maximum number of gallons he can mix. So the max number of gallons is 14, and that's being made when we have 6 gallons of paint A and 8 gallons of paint B. And we know it's 6 and 8 because when we defined our variables, we said let X be the number of gallons of paint A and let Y represent the number of gallons of paint or color B.